live from downtown Mill Bay.
Where are we?
Yeah, we are.
Are you sure?
Because we're downtown.
That's all I was asking about.
Pardon?
We're live.
I mean, if up there is uptown,
I understand.
then by definition we have to be downtown.
What if that's downtown and we're up?
But nobody calls it downtown. English is defined by common use.
That's entirely true.
Yeah, wait, what?
It's like when people argue, is it a GIF or a GIF?
Don't even start.
Obviously, it's a GIF.
Yeah.
Because that's what the majority of people say.
Except
it's
programmers
right.
say GIF.
But it's not defined by definition. It's defined by common use.
So,
He's wrong. And that gives me
phosphorus
so
is
much
spelled
pleasure.
with two F's.
If you can get enough people to do that, it will change.
I kind of really want to do
Yeah.
that now.
Yeah.
Oh, so to make them stable, do we just need to bond?
Oh, that's going to be one of the questions. I'm going to ask someone at random. Violet, how many protons in sodium? 11 protons. And what's the ring structure? Sorry, start at the beginning. Excellent. And then, what are the number of protons, Bo, in chlorine?
Protons?
Protons.
17.
17 protons. And what's the electronic structure?
287.
2, 8,
That's
7. And then the question is, what are these stable on their own? These are the atoms. Yes.
Oh, they're not right now
They're not right now.
because they do not have full valence shells.
They do not have full valence shells.
The sodium can react with chlorine to go sodium chloride by sodium giving away its.
So sodium can give away its electron, and it can be tearfully accepted, and then we end up with sodium chloride. And writing all of this out turns out to be a really complicated procedure. Because we have to write all of that for a Bohr model, even to make a simple Bohr model, and it would be far easier to use what kind of model or structure? Lewis. So that's what we're going to do next, because Lewis is far easier to show this. We're also going to make it just a little bit, we're going to put in a wrinkle and discuss all these. Is anybody not done with this before I turn the page? I see some people ready. So what I would like you to do is on this page, I would like you to draw the Lewis, not for sodium and chlorine. Please cross those out, because those are too easy. We just did those. That's insane. Why would we do those? Let's do potassium and
No.
nitrogen.
Yeah. I like that.
One of each.
I'm going to leave the number up to you with the caveat it should be the correct number. So, and I'm asking you to draw the Lewis dot diagram of the ion. You can start off with the atom, and when I go through it, I'll probably start off with the atom and then make it the ion. But you need to draw out the correct number of ones, which will probably become more obvious once you draw the first two. So we'll start off with potassium and nitrogen.
Cough. Yes, I just vocalized the word cough.
It's like students I find in the house who say lol. You could just laugh. You don't say lol, you text lol.
Exactly.
Excellent, you started, but those aren't the ions. Those are the atoms. You need the ions. And then you need to figure out what did you do to get those ions. I like to think this was a long thing to be taken away so that everybody can be as far away from it as possible. out the atoms, you'll convert those atoms, if you're trying those atoms into ions. So the next step is to convert them into ions. You're also doing a thing, it's not technically wrong this year, but you're pairing them in advance. So when you drew nitrogen there, you had that, right? So you're pair. But when you draw, go around like 1, 2, 3, 4, 5, then automatically give you the right number of pairs and the right number of singles. The other way of thinking it is you can't have empty spots. If you have an empty spot, you're going to run away. It's not technically wrong this year, but it's got a lot of empty. Oh, there is no covalent bonding. So no drawing circles, no drawing lines. That's one of the things I'm looking right now, is anybody drawing bonds? Okay, no bonds.
No bonds. No.
No bonds. This is a spy film without a bond.
What?
Yeah.
What?
Yeah.
So what is it then? Kingsman?
No. No. It would be born identity. Yeah. What are we at? You need ion. Oh, you still need ions though.
How do you label
You just have atoms.
Wait, I don't know what.
Oh, nice. Yeah.
label electrons?
Oh, Hobart, that one's.
What are we supposed to do? Can we just draw the ions as well?
Let's see. You did something very clever, but it's also.
Wait, like now?
Oh,
This
no,
is
that works.
Wait, hold on. How's it incorrect? Like, it is. This is.
Is it stable?
Well, it's an ion, but it's.
But ions add or subtract electrons to become stable. Is it stable? Excellent. Oh, yeah, you've done two clever things. Oh no, if you take it away, it's just empty. So just make it 0. I see what you did, and it's also
I
clever.
did it stupid. I have been foolish.
Oh, you do?
You did
Oh,
it,
you're
stupid.
So what do you need to do to become stable?
I just talked to you one time.
Is this an ionic compound or an ionic
Full valence shell.
bond?
There you go.
What's the difference?
Oh, where did you get it from? Oh, well, what? That one has your +1. There's a second. That's not +1. So how did that? What did you have to do there?
Like this.
Yeah. And where would it go? Yeah. But how many do you need? Wait, I don't know where that one.
What? No.
Not black. That's
Oh,
not black.
No.
very close. However, we don't want Bohr models. We want Lewis diagrams.
Where are you testing?
Is it her on YouTube?
Oh, you'll have dots. They'll just no bonds. So they'll just be octet rule or empty, like 8 or empty. Okay, I'll start off because I think I've seen in most
That means there's one less.
the atom.
Go away one. So it's not. It's just a full shell. Wait, I'm confused. Is it like 8 valence? So it would be a full.
But we don't draw the second. We just leave it on our edge.
So I just put 0. So I just put okay. That's all I need. You're
Okay,
I did it.
Aiden, chemistry 10.
What?
Okay, what do we need to do to make these ions? Yeah.
We need to have enough potassium atoms in order to.
Well, just the potassium. What does the potassium need to do to become a
away
neutron?
its ion.
Give away its electron. So let's take that and I'll I'll ungroup it, and I'll literally take away its electron. And who's going to take it? Nitrogen. Because how many does nitrogen need? 3. Now, some people did a very clever thing in that they saw that that was then +1, and then they essentially did that. And they said, oh, that's -1. Done. And I'm like, yes, you cleverly took the electron and put it where it belonged. However, this isn't stable. Because how many electrons does it need? 2 more. So where does it get those electrons from? Not another nitrogen. More potassium. You just grab more potassium. You have as much potassium as you need. So, boom. And we're going to need 3, so we're going to go like that. So that one will go there. We'll put that one there. And then Aiden, on the task. That makes the nitrogen -3. It has a full octet, so it's stable and an ion. If you look on your periodic table, the colorful one that you have, you'll see that it matches the charge it's expected to have when it becomes an ion. These are all +1. And so this is why I changed the elements to show a little bit more of a complicated version, to show what this compound becomes. Now, there is no bond between them. What holds them together?
Electrostatic attraction.
Say that again louder. That was great.
Electrostatic attraction.
So, held together by electrostatic attraction.
It's on the sheet.
It's literally right there.
How do you draw it?
Aiden, I think I'm gonna have to move you. You keep drifting into conversations about the gym, waking up. Let's try one more time. Electrostatic attraction is just the attraction between the positive and the negative. So there's no actual bond per se. Covalent, they're there because they're sharing something. So for example, you may at some point in the future choose to live your life with someone for the rest of your life and get married. And then you buy a house and you have 7 kids. And then you realize that your partner is a total jerk. You dislike them. You don't know how you ever fell in love in the first place. However, you're still together because you share the house and the children. So that's like a covalent bond. You're not attracted to each other. You just have stuff in common. And both of you refuse to let go. Whereas this one, there's no shared common things between them. They just are really attracted to each other. I won't get into the fact that nitrogen is so attractive there are 3 of them in some sort of weird polycool. We'll leave that alone because that's where the analogy starts to break down. However, they're held by electrostatic attraction. In fact, they're held by electrostatic attraction if we're going to go in the whole polycool phase. I'm going to group that because then I can do this. These are +3 altogether, and they are, of course, attracted to that nitrogen. But they're attracted here. If a nitrogen wandered up over here, would it also be attracted to them?
No, because they're all stable.
Pardon?
They're all stable, so.
No, they're stable, but are they also positive?
Yeah, they would.
Would they be attracted to
Yes.
another negative?
Yes.
Yeah, so another nitrogen would be here. Also attracted to them. And then I'm going to take all of these. And I'm going to group those. And then I'm going to do a thing so that I can grab them.
Oh, no.
And then on the other side of them, 3 other wandering triplets are like,
Getting
hey,
a little bit weird.
come on, my mouse is not working properly. Are like, hey, how you doing, nitrogen? And that just keeps repeating forever. I look on this page because I didn't want to draw that structure because the diagrams for them are way more complicated. But if we were to look at this as sodium chloride, there is no such thing as one sodium and one chloride. They are all chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine. I could do this all day. They're just a repeating pattern of positives and negatives that are all attracted together. They're just a big cult living in a house, all attracted to each other all the time. So at that point, the entire marriage and relationship analogy probably breaks down. However, we have 3 chlorines across, 3 chlorines down, and 3 chlorines deep. How many do we have in total in that cube? 3 times 3 and 3 is 27. And how many sodiums do we have if we see the same kind of repeating pattern? We should have the same amount, 3D, going to it. What the part of the problem is that there should be, to show the proper model, one here. And I think the artist didn't want to show it because it should be even in terms of the number. But they repeat in that pattern. Now, that's a really small crystal. You could have a, sodium 5,000 with chlorine 5,000. You could have sodium 127,564,923 would be with chlorine 127,564,923. Just depending on the size of the crystal. That would still be a pretty small crystal. The numbers are probably much bigger than that. However, why do we then say that the actual formula is NaCl? What is the same about all of them, if not the number?
The ratio.
Yes? They have a 1-to-1 ratio. So the formula for ionic formula is the ratio. Not a ration, as I just wrote. But then I'll underline it in there, and I'll maybe put in brackets, it is the simplest ratio. So there cannot be such a thing as Na2Cl2. We would immediately cross that off and make it NaCl. Because none of them have a beginning and end, they all go forever. And we would never call this a molecule. Molecules have a beginning and an end. This we call a formula unit, or an FU for short.
Oh, that's
Yeah.
weird.
Now I'm going to contrast this with a covalent compound, H2O2, which is hydrogen peroxide. This has a definite structure. It is HOOH. It has a beginning, it has an end, it has an alpha, it has an omega. It is an entire thing. This is a molecule, covalent, whereas that is literally it, and even gets the shape right because it can rotate and be either way. So oxygen, oxygen, hydrogen, and so we reserve the word molecule tends to be for things that actually have a distinct structure, whereas these are just formula units. Anybody still writing down? Are you still writing?
Sure.
Okay. The way you say sure, though, it's like, well, I could, but I also don't have to. So we go back to here. Which is the cation and which is the anion? Nope. Yes. K is the cation, so just to review some of our terms. Cation. Someone else, who is the anion? Yeah. And this N or that N? Bottom one. Thank you. That's the anion because it's negative. So we did that. We already defined electrostatic attraction. Oh, this is an ionic compound. That is a lot in there. What type of elements make up an ionic compound? Yep.
A metal and a non-metal.
So we have a metal. And a non-metal. There are exceptions to the metal-non-metal rule. So the overall, you must have a cation and an anion. And we'll see a few examples of that a little later on. But it's almost, especially if they're single elements, it'll be a metal and a non-metal. And a compound. The ionic bond, we already did. What makes up the ionic bond? The magic phrase. Because there's no visible bond, what's the force that holds them together? Electrostatic attraction. What kind of elements? We did that. What is the charge? Oh, what is the overall charge of our ionic compound? It's zero. They should always balance each other. So the overall charge is that they will always either attract their opposite until they even out. So as you had to do here, nitrogen needed to be -3, and so it kept attracting potassiums until it had all of its electrons, and then you get that particular ratio of 3 to 1. And what holds it together, we already said that. That's the electrostatic attraction. What is the formula? What if I was to give this an actual formula? What is the formula? It's not a trick question. What is the formula for potassium nitride? Yes? Right. So if I was to write it out, I'd write K N. Where do I put the 3? Yeah. In front of the K? The small ones. So when we have formulas, we would write it subscripted in front of the element, and that would tell us the number. We never write 1, so the N doesn't have a 1 next to it. It is technically wrong to put it there because we just don't, because chemists are lazy. And so that is the formula. I just said it, but if someone else can guess, what is the name of this compound? I've already answered you a few times. I don't actually know if I formulated this. You guess?
Tripet.
Nope.
No.
Now, if any of you thought tri, that is covalent naming.
Oh yeah.
So don't.
Potassium 3.
Nope. Yes?
Potassium nitride?
Potassium nitride. Notice there is nothing that tells you how many atoms there are. From this name, you don't know there are 3 potassiums. But you are expected to be able to figure it out. How could you figure it out? Yeah. No. Now, if you will notice when we are going to do the brackets with the Roman numerals, but we only do those for certain types of elements. We don't do it all the time. So they cannot mean the number of atoms, because if they did, then we would do it all the time. So they mean something else. Yeah?
You can tell because that's just how it is. There's no other way to...
Right, but where could you look up how it is? What is it that allows you to do that?
Periodic table.
Periodic table. What would you look up?
The potassium and the potassium and nitrogen.
But what would you need to know about it?
The protons and by extension the electrons.
And then that gives you the...
The formula. Like it gives you the charge.
Ah, there we go. Gives you the charge. Everything in this column is what charge? Another way. What is the number of valence electrons? Aiden?
1.
No? What are the number of valence electrons in this row?
1.
But I think you two, rock, paper, scissors. Excellent. If you can move that. Aiden? How many valence electrons is in this column? 1. So if we were to take that away, what would be the whole charge of the whole column? Other way, +1. You take electrons are negative, so if you take it away, this entire column, once you take away its valence electrons, becomes +1. What was this column? How many valence electrons for everybody? How many valence electrons are in here? 2. Take them away, what's this charge? +2. So you can count along. +1, +2, +3, +4, and -4, because it's right in the middle. Nitrogen? -3. We're going to start adding them. -2, -1. And that -1 does the whole column. -2 does only up to here. And -3 only goes up to here. Plus or -4 basically is there, although it's sometimes there. That +3 works for here. Works for here. And then there's 2 more. Zinc is always +2, never needs Roman numerals. And silver is always +1 and never needs Roman numerals. And on your periodic table, you can look those up if you ever need to know them. I have it in 2 places that I'll show you next day. But those are the charges, and you don't need Roman numerals because we can always get them from the periodic table. You can either look them up on the colorful one, or you can just count on the other one. +1, +2, +3, plus or -4, -3, -2, -1, and of course 0. So you can work backwards. You can look up and go, oh, potassium is +1. Nitrogen is -3. So if I have potassium nitride, what number does both 3 and 1 go into? 3. So we need 1 of those and 3 of those. K3N. What's next? Oh, I had a student in one particular year in Science 10. They always forgot what a cation and anion was. So this is just there in their honor. If you ever forget, you can come here and gaze at the little kitty cat and the angry
But I like
onion.
onions. Onions are good. I like them.
No, but they make you cry,
Oh.
right? I like onions too, but when I cut them up, I get swimming goggles. If you put swimming goggles over your eyes, the sulfide gas that comes off can't touch them. You don't make sulfuric acid in your eyes, no crying.
You could also freeze the onion beforehand.
Freezing does help, but goggles make sure they don't come anywhere near you. That one's boring. We'll do some of this. We're going to do simple. We're going to do Roman numerals. And then we're going to do polyatomics, just to give you an idea. But let's start off with, that quiz is dumb. Let's do this. I would like you to name those. Go ahead.
When are we gonna get our, wait, did we get our text back yet?
Almost. Not quite yet.
Almost.
Are we
Almost.
getting them back today?
Why not
said you wouldn't.
Wait, really? Are we getting them back tonight?
No.
Ah.
Well, everyone else might,
Oh,
but
oh.
you in particular won't.
Please,
Feel so bad.
please. I'm begging.
Group maker.
I beg of you.
Excellent. Arnie, you can join any group you like. I would like you to take your partner, do those 3 names on the whiteboard. If you'd like to grab one of those small ones, just have them up at the end. You can do that. Grab your partner. Go name those 3 things.
Are you drawing them out, or can you just like?
You can just name them. I'll put them back up in a moment once everybody has their partner. Ooh,
Naming it.
you're naming it.
I learned it with the first one. Maybe it's wrong. Maybe it's. Laura, can you write that?
There's also room at the back if you want to use the little whiteboards. Also, we can pull this back so people can work better to the right. Okay, sodium chloride, sodium chloride. I think everybody got the first one. Double check your spelling.
Oh.
Oh, excellent. Spelling
It's not
confirmed.
font. You don't need to buy
Excellent. Yeah, no monoditride. And aluminum oxide. Excellent.
I just did that.
And then. Oh no, stay up there. I'm about to give you more.
Oh.
Oh yeah.
Oh.
Let's get the names for. Oh, perfect. Yes. The famous crime scene drama CSI.
What?
CSI.
Yes.
Yes. Yes. And and from Game of Thrones, Cersei.
Yep, cesium. It's cesium iodide.
Cersei. And then straight from the Princess Bride, Li3 AS. Everything I'm giving you is ionic. We have not done any covalent naming yet. Does that make sense? Go with whatever makes sense. I'm not confirming nor denying anything at this point. You can consult with other groups. I'm going to stop at those 3. Once you have those 3 in your versions, then you can sit down. Teaching in shoes is so passe.
Give me my chair back. I like my chair.
There is 8 minutes.
I like my chair.
Not quite yet, because then we will,
Yeah, actually, probably is.
it'll just be another chat.
That's how I would
Who's your advisor?
Mr. Stevens.
Excellent. If I was him, I would probably say things like, choose where you sit so you get the most out. If you're sitting beside people you like to talk to, probably won't learn as much. Like if I sit in a staff meeting, I have to sit far away from some people, otherwise we will chat the whole time. Although to be honest, we don't, staff meetings are more announcements than they are learning sometimes. I have to remember I am being recorded.
You are
Okay.
or
Looking along, cesium iodide, cesium iodide, cesium iodide, cesium iodide, cesium iodide, cesium iodide. We all did very well. Well done. Circe turns out to be strontium selenide, which is kind of odd, but everybody seems to have gotten strontium selenide. Where's there? Oh, that one skipped it. Strontium selenide and strontium selenide. And the last one, the reason I said it was from the Princess Bride, most poisons, if you take them, will kill you. And if you take them a little bit over a long period of time, they'll still kill you. But arsenic is one of those weird poisons that if you take it in low doses, you can actually develop a bit of a tolerance for it. Which is, how many of you have seen the movie, The Princess Bride?
Yeah.
Excellent. So when he talks
That's
about
small.
iocane powder, it has to be an arsenic compound because it's one of the few things that actually has that kind of thing. So this would be lithium arsenide. When it's a non-metal, what's the rule? Ide. You change the last one to be ide. And nobody did any 8s or ites. I was expecting at least one. Congratulations. So there's a couple of things I have to give you before we're done. One, you'll have, 5 minutes now if you want to continue working on this, but I have a handout. Where's the rest of it? 1, 2, 3. And that up for now. 1, 2, 3. Now let me find the other one.
Thank you,
Nope. Just had them all. So hold it. There we go. 1, 2, 3. 2. One more or 2 more? Just one more? Only the first page. You don't. This is pages 1 through 5. You don't have to do all of that. Next, I have your test results. So I'm doing something a little bit different this year. If you want to see your actual test, come and see me during tutorial. Or the day before we do like our chemistry cumulative, I will give it back to you so you can go through it in detail. But I find when I do it as a whole class, there's usually quite a large number of people who don't necessarily go through it in detail. And what I really want you to get out of that is a list of what you're doing well, and what you might need to go back and review. So I've done a new thing where I have given you a list of things you did well, and what you might need to go back and review on. In order to make all of them, they are kind of generic-y, because I did do a lot of copy-pasty types of things. You have on top your overall percent, which is a traditional marks right divided by total number of marks traditional percent. Below that, you have your critical analysis percent and your communications percent. If you take those two numbers and you average them together, you will not get your overall percent because some questions, particularly long answers, may overlap. They're both critical analysis and communication. And you can see which ones are which when you look it up online and see your answer. Yes?
So you can come tomorrow during tutorial.
Yeah, you can. And you will get, like I am going to give you back your test, but I find the day that everybody is most interested in what I got wrong last time and going through it in detail is right before the next test that covers the same material. So you'll get it definitely. But this way, you'll have some feedback and you can also come and see me. So, Liam, I was about to just start handing it out and I realized, no, they have names on them. Calder, Grayson, Layla, Jamie, Violet.
How did you do your one?
Just to
I
see
thought I
your
did one.
paper.
And Rachel.
The paper.
Oh no, you got a 90.
The task.
Nick.
It's not
And Lauren.
absolutely horrible. I mean, this part's kind of, but the overall, not horrible. And I'm pretty good at my communication. Look at that.
Here, you only get your
Noah.
grade, but you want to
Oh, my communication always screws me over.
My critical analysis always screws me over.
And Matthew.
My brain's very good. My
Honestly,
mouth
I
is.
didn't expect
Miyabi?
any less or any more. So like,
My brain is very
Graham.
good.
What about here?
See, 100 in my brain part, but in the communicating part, no.
Aiden.
still just so good.
Yuma. And Rose.
My communication.
Wait, what did ours do? It's still.
Okay. Now that you have it, and you're looking it over, I should have said this first. I don't know why I didn't, because obviously you want to look at it right away. That is yours to keep. That tells you your mark, your overall. You can come back in and see your test anytime. But as you're looking over your mark, I will say the class average was reasonably high. For the past few years, especially since post-COVID, I've been doing a lot of review of grade 9 chem. And I think we're starting to not need it anymore because we're starting to get out of the cohort that didn't know grade 9 chem. So I'm expecting the next one, the average will be a little lower. But if you want to keep that, keep working hard. If you are finding balancing or anything a little bit more difficult, make sure you see me for extra help. You will probably have a cumulatively type of test around November 18th, 19th. Okay, about 3 weeks. Just to give you a heads up, and I'll post it on the Google Classroom as well. Does that make sense? What block do you have? Oh, so what? Since it's going to be today. Sure.
He said why is it, well, just from your, how teachers talk about your understanding, it doesn't seem like,
Thank you.
it doesn't seem like your understanding's bad. In fact, I feel like you have a few more concussions and still be an above average student.
That's a compliment.
Yeah.
That is a compliment. It's a weird compliment, but it is a compliment.
I appreciate it.
Yeah.